Welcome to a new video, which is the third part of Trigonometric Identities topic. In this video, I'll be focusing on finding equivalent expressions in trigonometric identities. Without further ado, let's get started. In our previous videos, guys, I already showed you the formulas which are used in this topic. We're going to make practices, guys, in this video. And as a first question, we have 2 minus cosine square x divided by 1 plus sine square x, and that is equal to 1, guys. Here, the right side can be written as 1 divided by 1, right? So this is actually 1 divided by 1. And if you apply the cross multiplication here, guys, then this part, which is the denominator, right, times 1 is going to be equal to numerator times 1, which is in the denominator. And once we do it, we're going to have 2 minus cosine square x times 1, which is the same thing, is equal to 1 plus sine square x times 1, which is the same thing, guys. And from here, guys, what I'm gonna do is I'm gonna send this negative cosine square x from left to the right, guys. Once you do it, it was negative on the left, and if you send it to the other side of the equal symbol, then it's gonna be positive. So in the next step, we're gonna have 2 is equal to, guys, 1 plus sine square x plus that cosine square x, right? Cosine square x. For the people who don't know what I did here, I recommend you to take a look at one of my previous videos about shortcuts in calculations. Anyway, here, guys, we have an identity, sine square x plus cosine square x, and that is 1, guys, right? So the left side is 2, and on the right side we have 1 plus, from this part I have also another 1. So actually it is 2 is equal to 2, and as you can see, the left side is equal to the right side, which indicates that the given expression is correct. And we have next question, guys, and it says again, show that sine square x divided by 1 plus cosine x plus cosine x, and that is equal to 1, guys. I'm going to put two algebraic equations, guys, here. I'm going to put one trigonometric identity, which I'm going to use in this question, guys, and that is sine square x plus cosine square x, and which is equal to 1, guys. So here in the numerator I have sine square x, right? So if you take this sine square x and if you send this cosine square x to the right side, then we're going to have sine square x is equal to 1 minus cosine square x, guys. Here 1 is the square of 1, right? And cosine square x is the square of cosine. Cosine x, it's square. So actually we are subtracting one square from another square. And that reminds me of one famous algebraic equations, guys, which is, if you remember, a square minus b square. What was it? This is, guys, a minus b times a plus b, guys. So here a is, we can suppose that a is 1, b is cosine. So how we can write it? These are square, right? So we're gonna have 1 minus cosine x times 1 plus cosine x. So instead of this sine square, I can write this expression. So once we do it, then we're gonna have 1 minus cosine x times 1 plus cosine x divided by, in the denominator I have 1 plus cosine x plus, I have another cosine x here, and that is 1, guys. I need to prove this. And if you look at this fraction, guys, here I have 1 plus cosine x, and in the denominator I have the same thing. So we can just cross them out, and the leftover is, we have 1 minus cosine x divided by 1, which is the same thing, plus cosine x, and that is equal to 1, guys. On the left, as you can see, we have negative cosine x and positive cosine x. So you can just cancel them, and the leftover on the left is 1, right? We have 1 here, and on the right also we have 1. And as you can see, the left side is equal to the right side. So that indicates that the given expression is correct. And this question, our last question, guys, in this video. And as a last question, we have if 7x is equal to pi divided by 2, which is 90 degree, right? Which is 90 degree. And then show that sine 2x minus tangent 3x minus cosine 5x plus cotangent 4x, and that is equal to 0, guys. Here we're gonna benefit from a famous rule which is about complementary angles, guys. And suppose that, let's say, a plus b, and this is equal to 90 degree, guys. So the angles a and b are called complementary angles because their summation is 90 degree. So in such cases, guys, sine a is equal to cosine b, or cosine a is equal to sine b. Similarly, tangent a is equal to cotangent b, or let me put it here, or cotangent a is equal to tangent b, guys. So I'm gonna benefit this rule, guys, in this question. And because 7x means 90 degree, okay, so if this part is sine 2x, then how you can write it in terms of cosine? Well, because 5x plus 2x is gonna be 7x, right? So instead of sine 2x, I can write cosine 5x, guys, because 2x plus 5x is gonna be 7x, and 7x is equal to 90 degree, guys. That's why. Minus, instead of tangent 3x, how I can write this in terms of cotangent, guys? Because 3x plus 4x is gonna be 7x, which is 90 degree. So I can write this tangent 3x as cotangent 4x, guys. And write the rest of the question, okay? If we write the rest of the question, then we're gonna have minus cosine 5x plus cotangent 4x, and that is equal to 0, guys. And if you look at the question again, as you can see here, we have plus cosine 5x. Here we have negative cosine 5x. So if you add them up, then those are gone. Okay, so we have 0 from here. 0 plus, from here we have negative cotangent 4x. From here we have positive cotangent 4x. And again, if you add them up, those are gone also. So we can just cross them out as well. And the leftover is 0. And on the right, as you can see, we have 0. So 0 plus 0 is 0, and 0 is equal to 0. That means our given expression is correct. And about trigonometric identities, guys, I'm going to be doing one more video which will be about solving advanced challenging questions. And that's it for this video, guys. If you have any question related to the subject or related to the questions that I solved here, you can put them in the comment section below. Thank you for watching, and hopefully see you in the next video.